Okay, today we will be discussing questions that involve a series of redox using two compounds given in your question paper. Now, usually a series of redox reactions occurs, meaning there is more than one redox. Okay, that means they continue one after another. And compounds that can undergo multiple reactions usually are transition elements. So for those who have the transition element can exist in multiple oxidation states, right? Like iron and vanadium. So you have iron 2, iron 3, vanadium, got vanadium 2, vanadium 3 plus, 4 plus, 5 plus. All right. So when you look at the question and identify the element involved, you may want to consider picking up all the related standard reduction potential that involve your vanadium and the iron, knowing that they have more than one oxidation state. Now, bear in mind, this question is in winter 2016, paper 41, question number 4. Back then, data booklet was given. Okay, so the student have to go and identify and pick up all the related standard electrode potential. Okay, but for 2022 syllabus onwards, the information will be extracted and given to you in the question itself. All right, it can simplify for you for the 2022 onwards, but for the before 2022 syllabus, all right, the student have the whole data booklet and they must show that they are able to pick up related equations. Okay, now the word that we want to focus on is access. Why access? Access means you can stand by and do other things as well or do more redox for you. Okay, yeah. Now, for answering winter 16, which involved the data booklet, the students back then need to go and pick up all the related equation. All right, so I have picked up all the Fe, iron related and the vanadium related equations. And number one, I always mention to please align everything. Okay, align the table from most positive to less positive. So what you can see here, I've arranged from most positive, positive 1, then it decreased positive 0.77 and decrease all the way to negative 1.20. Okay, it is my go-to habit to so-called practice any electrochemical questions. Okay, that's my first thing I always ask my students to do. Now, then after successfully arranging everything ready, then you want to go and circle your iron 3 plus. Okay, so let me go and circle iron 3 plus here. I spot one iron 3 plus here. I spot another iron 3 plus here. Vanadium metal is only down here. Okay, no more. Okay, now first, which iron 3 plus will undergo redox with your vanadium metal? Now what you can see here is the more positive E value will undergo reduction. Bracket H is reduction. Okay, so Fe3, both the 0.77 and negative 4.04, right? They are more positive than the vanadium at negative 1.20. So both of them actually can undergo redox with the vanadium, right? But the question now is, which Fe3 plus will undergo the redox in higher probability? Okay, so first we would like to calculate the E cell for the first variant here. So this is version 1. Version 1, okay, how to calculate E cell? Your E cell will take the more positive minus the less positive. So hence you'll calculate positive 1.97. Now if you look at version 2 here, when you calculate your E cell, you get minus 0.04, the more positive version, minus the less positive version. Hence you will obtain a calculation positive 1.16. Now since E cell, both versions are positive, it means that it is feasible where iron 3 will undergo reduction and vanadium will be oxidized. Okay, but which one will we pick? We will always pick the more positive one, which is positive 1.16. 97. We will pick this. Okay, now we're going to construct a redox equation first. Okay, so the first redox equation over here, we will construct, which is Fe3 plus. So we pick the 0.77, okay, and then vanadium will undergo oxidation. Now to balance the equation, 2, 2, and 2. So these 2 and these 2 will cut. The first redox equation occurred, okay, it will be 2Fe, 3 plus vanadium to give 2Fe2 plus V2 plus. So this is your first redox equation, okay? So they are related this way, with the E cell value of positive 1.97. So what we are learning over here, takeaway message is we will choose the more positive E cell in exam, all right? Because more positive E cell means more spontaneous. Version 2 also spontaneous, but less comparatively. Okay. Now, then how did the marking scheme came out not V2 plus? Okay. Now, because subsequently you realize that your vanadium from V2 plus, Fe3 from Fe2 plus, right? Do you realize Fe2 is also here? Okay, so now you will undergo another second redox equation. Okay, so you will circle up this V2 plus, you will run the second redox equation. Now, how do I know there's a second redox equation? Provided number one, you have picked up all the related vanadium standard reduction potential out, or standard electron potential out. Now, second, student also needs to be aware that the Fe3 plus 0.77 is more positive than the negative 0.26, if you realize that, and you did pick up at first place. Okay, so what it means that iron 3 plus at 0.77 will undergo reduction, and the V2 plus that was being formed is less positive. He will undergo oxidation. Correct or not? So this is the second redox equation. So if you want, you can go and calculate the E cell here as well. Okay, but that's not the main part of this discussion. Okay, so can we continue from first redox? Okay, so what happened here is I would like to take the V2 plus that's formed over here. Okay, I have to copy up the first one again. I have to copy this one over again. Okay, so Fe3 plus electron to give Fe2 plus. This is at the 0.77 version. And from the first redox equation, I have one V2 plus. Okay, one V2 plus. 2 plus will undergo oxidation to give V3 plus. Right? Not? So you have excess Fe3 plus. That means you have a lot here. I can use another Fe3 plus to undergo the second redox equation. So I'm going to bring this thing down. Okay. Now, so this electron can be cancelled with this electron. Okay. So what happened here is Fe3 plus V2 plus to give Fe2 plus and V3 plus. Okay, so that's my second redox equation. Okay. Now, then third one, when you form V3 plus here, do you realize V3 plus is also here? Correct? You see a similar pattern, right? Okay, V3 plus E value is more negative than your 0.77. Correct or not? So I'm going to utilize the V3 plus here. V3 plus will undergo oxidation because he's more negative. And I need to bring back my Fe3 will undergo reduction. So you receive one electron, I donate one electron. Okay, so that this V3 plus and this V3 plus can cut now, I use from the second equation. So my balance equation now will be Fe3 plus H2O. Okay, to give Fe2 plus 2H plus and VO2 plus. Now you can see that there are three redox occurring now. Okay, yeah. Now before I sum out everything, okay, into one equation using the three colors. Okay, so what happened here is V3 plus, right? It will form VO2 plus. Okay, your V3 plus will undergo oxidation to form VO2 plus. And for those who are wondering, this VO2 plus is, well, also this VO2 plus up here. Okay, so can a redox occur between the excess Fe3 that I'm circling now, very obvious, with the VO2 plus up there? The answer is no. Okay, why? Because your Fe3 plus, right, he is more negative, all right, than the positive 1.00. So Fe3, Fe2, all right, 0.77 is more negative. They actually prefer to undergo oxidation in this case, which is Fe2 trying to oxidize to Fe3, whereas your, these two here will try to undergo. So hence, this is not feasible. A shortcut trick that I normally teach in class is basically, if the reactant position is 1 at the top left corner like this, okay, I want you to look at the highlighter, or maybe I use the, okay, I use the highlighter here. Now, if you realize the first one, the blue one, can you see I highlight the Fe3 plus here with my highlighter? The first one is the left finger on top and the right finger below. Do you see that the two reactants, okay, the position of the two reactants is left finger on top, right finger below, right? Then after that, you look at the second redox equation. The second redox equation also shows similar pattern where left finger is on top and the right finger is below. Correct not? And you look at the third redox, okay, you also see a similar pattern where the left finger is on top in blue color and the right finger is below. Okay, this is just a shortcut trick that I do, okay, to know whether a redox can occur, not occur. But disclaimer, you only can do this if you align everything from the most positive to the least positive. You cannot do that in an alphabetical arrangement or a random standard electropotential series given by your examiner. All right. So that's the reason why I always ask students to arrange from most positive to least positive. Then you can see the symptoms. But if you go to the green color pen, which is the VO with the charge of 2 plus, which is top right corner, right, you realize that you're trying to force. You're trying to see this thing here called left finger is below and your right finger is on top. Now this is not feasible. Okay. To make it more wholesome, right? How do we prove to the examiner that it's not feasible? I use a red color pen, indicate no. Okay. So let's say I want to pick the first one. Okay. Now VO2 plus, in this case, you only can shift left. Shift left means undergoing oxidation. Okay, undergoing oxidation means I need to make the value minus this one. Okay, so this is my oxidation equation, my half oxidation equation. Now, Fe3 is on the left. You only can shift right, which is reduction. So this is my half reduction. So when you undergo forward, right, reduction to the right-hand side, right, you take the value as it is, which is 0.77. So when half oxidation and half reduction add together, right, you realize your E cell value turns out to be a negative E cell value, which is 4.23. E cell value now is negative. Okay, this is a full redox. Redox is half oxidation, half reduction. So this will prove to examiner that Fe3 and the VO2 plus charge cannot undergo redox. Okay, yeah, because the E cell is negative. Here, so I also teach you how to prove that E cell is negative. Okay, you put your finger at that particular compound, see whether you can shift left or shift right. If you're shifting left means oxidation, please flip the symbol to the other now, because the E value here are all in reduction manner. Okay, now, so I'm gonna construct only one equation. Can we take all the three equations, the blue, the orange, and the red together? Okay, so I probably need some space over here. So I'm going to add all three equations here. So it's like a little bit of maths now. And that's V2 plus. Okay, second one here, the second redox that continued was here. So you can see these two and these two can cut already. okay? And then the red color version here, so this Fe, where's my vanadium? Good question. I forgot to get my vanadium, okay? Vanadium ions. So this one and this one can cut. So equation 1 plus equation 2 plus equation 3. So how many Fe3 plus we have here? 4 Fe3 plus vanadium plus H2O to give how many Fe2 plus here? 4 Fe2 plus 2H plus and BO2 plus. Is our charge balance? Let me have a quick look. Correct. On the 12th, we have a positive 12 charge. On the right, we have a positive 12 charge. Correct. Okay, so this is the answer. And if you want to check the marking scheme, attached down here, as you can see, are we correct? Correct. Okay, so much work for a 2 marks question. Well, would it or not, I'll let you decide. Okay, but I think it's a necessary skill that we need to learn. Okay, now I've just demonstrated and explained how to solve questions that involve a series of redox. Okay, first lesson we learned is if you are still solving the 2021 and beyond this question, you need the data booklet. And if you need the data booklet, right, please align everything from the most positive to the less positive, lesson number 1, if you're doing 2021 and beyond. Okay, well, it still does apply to 2022 onwards. Okay, number 2, I think this is the principle. More positive E value will undergo reduction in a higher tendency. Less positive E value will undergo oxidation. No choice, they are forced to. Lesson 3 is we will always choose the more positive E. So if you have variant 1 and variant 2, right, please pick variant 1. Okay, which is in this case my variant 1, which is a more positive E cell value. It will occur in a higher probability. Okay, yeah. And then you also learn how to construct the full balance equation over here. I also did teach you, number 4, how to prove to the examiner that it's a non-spontaneous reaction. And how do we do the calculation? Where is it? The red color pen down here on the left corner. Okay, now if you would like to test yourself, you can go and attempt this question all over again, which is Winter 1641 question 4. I'll give you another one here. Okay, over here. So you can try to solve a more recent one, which is March 23. So as you can see here, March 23, data booklet is no longer provided. The examiner already gave the related equation. So you do not have any more than this. Good thing you only have 4 equations to look at. Okay, and this one also used the similar skills, and you realize they still use the word excess. Okay, now even though they never use the word excess, you may also want to consider a series of redox. It's just that excess just makes me more confident that, you know, with a higher probability that it can occur a couple of few reactions in one go, especially when we're playing with transition element, things like iron, vanadium, manganese type. Okay, so you can go and attempt this. Now, if you want a recording regarding March 23, please do leave a comment or let me know in the video, or you can give me a text and I'll try to do it as well. All right.